Okay, let's have a look at this example here. It's from the Oxford IB Applications and Interpretation SL textbook. This particular example has mistakes in it, and having worked backwards, I found that the mistakes are that this is wrong here. That should be 19, 1.3 squared. So we'll change that. Okay, so that's sorted out now. It's 19, 1.3 squared. And in your Inspire or your T84, go to probability, distributions, normal CDF, and put that in from minus infinity to 17, using that as the mean and that as the standard deviation, 1.3, and you'll get that answer there. Okay, for this one here, it's very similar. We use that for the mean. Again, it's normal distribution, and that's the mean, that's the standard deviation, 1.3, and our domain here, or the range of the domain, is going to be from minus infinity to 21. Okay, so looking at their diagram here, it's going to be from minus infinity to 21, so it's going to be this region here, which is going to be 1 minus 0.062. Okay, if you just put it directly in the calculator, you're just going to get the answer. Because remember, the calculator is measured from the left, so that's our minus infinity, and that's 21, so we're really shading in that area there. What they've done here is, because 17 and 21 are both 2 from the mean, they use some symmetry here. Because they've already found that as 0.062, they know that above 21 must also be 0.062, and then what they've done is just 1 minus 0.062. On your calculator, though, you can just put from minus infinity to 21, and you will get that answer. Okay, for C, they want the probability of T is greater than or equal to 20.1. So just ignoring the way they did it for a minute, in the calculator, you just need to put the mean in again as 19. The standard deviation is 1.3. And using normal CDF, you need to do 1 minus from minus infinity to 20.3. Because remember, it's measured from the left. Okay, and that will give you the answer. Now, the way they've done it here is, they've used this information here. Now, this came from another source, but basically it says 1 standard deviation away from the mean is 68% of the data points there, and or the values, and 95% are within 2 standard deviations from the mean, and 3 standard deviations from the mean is 99.7%. So over here, the way they got that 68 is it came from that. Okay, the reason they divided by 2 is because of the symmetry here, and we're really only interested in this one part here. So they've used that there, that information there to find the answer their way. But again, with the calculator, you just need to put it in with the mean of 19, standard deviation of 1.3, and put in find your answer. Okay, find your answer from 0 to 20.3, and then put 1 minus that, because 0 to 20.3 is from here all the way up to there. But you're really interested in this part because it said it had to be greater than 20.3. So we just want that area. So it's going to be bigger than 0.062, and it was bigger. It was 0.16 there. All right. And now let's have a look at D. The expected number of times the waiting time is less than 21 seconds in a sample of 107 chats collected by tech company management. Okay, so what they've done is they've either had it, the possibility is either, the outcomes is just 2, right? It's either less than 21 seconds or more, so that's binomial. It's 107 chats, and the probability of the waiting time is less than 21 seconds. Well, we saw from this one, the probability of it being less was B, and we found that as 0.938. So it's a binomial distribution, and it's 107 trials times 0.938, because that's the probability of being less than 21, and they got 100.36. Approximately 100 chats are predicted to have a waiting time of less than 21 seconds for the first question to be responded to.